Everybody hear me now? There we go. Okay, hello everybody. Thank you for coming to my session about designing a secure cloud blueprint. Uh, Everybody here should be well aware of what the public cloud is. The public cloud has revolutionized the business world. It allows for flexibility in development, fast, direct access to the internet, and is the quick and easy answer to business solutions that just a few years ago only had complex and expensive solutions. If just a little bit of information and a few mouse clicks, you can have the equivalent of an entire data center in your public cloud in just a few hours. The environments built in the public cloud can be scaled up or scaled down as traffic levels increase or decrease, so you aren't left paying for compute power that you don't need. You never have to worry about hardware maintenance or data center controls. That's all left on the cloud provider. And best of all, if you're utilizing on-demand pricing, if you don't need something anymore, you can simply get rid of it and never pay another dime for it. Now, before anybody goes racing for the doors or checking their itineraries, you didn't accidentally wander into a cloud sales pitch. What I've just mentioned should be old news to most of the people in this room. Cloud is one of the biggest things in the IT world and security. We talk about it constantly because it is such a large business tool. And as security professionals, it is such a large part of our business now because it is a new thing. It adds a new element to security. What I'm talking about today is cloud security. Now, I wish I could say that I was here to regale you tales of me defending the data in my public cloud against hackers and triumphing and saving the day, but what I'm talking about is a much less glamorous side of cloud security. I'm talking about the parts that often go undiscussed, but have a far greater impact on your day-to-day operations. I'm talking about identifying and overcoming the unique security, policy, and compliance issues that come with deploying to the public cloud and creating a public cloud design that requires a low amount of ongoing administration and cost. Now, with all of that, you might be asking, what makes public cloud security so different? Public cloud is supposed to be easy. Cloud security can be easy. It can be easy to deploy. It can be easy to administer once you have the proper design and training in place. Let's take a look at some of the ways cloud security differs from your traditional on-premise security. Public cloud environments can be deployed quickly and grow rapidly, which is great, right? That's why we want the cloud. But that ability to stand up quickly, that puts added pressure on project timelines. It can skew timeline expectations. When deploying to the cloud, you don't have any time added for ordering servers or ordering circuits, that time that you might have previously used for planning security. You might not have sufficient time anymore. Time you thought, I need this amount of time to plan security, might not actually be the amount of time you need. Rapid deployment capability also means once you're in the cloud, your environment can grow quickly. Once you've built your initial cloud environment, it may feel like the floodgates have opened, and everyone who has ever had a project put on hold due to a lack of compute power or bandwidth is suddenly at your doorstep. Without a design blueprint, you may find yourself constantly playing catch up, trying to secure and administer an ever-growing environment and adding security to applications that are already in production. Cloud environments are disposable. This allows developers to be able to build and toss what they don't need. That's the flexibility in development, which is an awesome plus for the development side. But on the security side and cost side to the organization, the fact that those environments can be destroyed when no longer needed often leave them out there, leading to large, complex environments that you have to administer and secure. These unused servers cost the organization money in multiple ways. They cost real dollars every month in bills from the cloud provider. They cost an administrative effort to administer the ever-growing and complex environment. And they can be especially troublesome in audit situations, as it can be hard to track down the server owners and or purpose of those old servers, or even if they're even still being used. That fast, direct access to the internet. In the cloud, that can cause poorly defined network borders. In your physical environment, your internet line comes in one place. That's your outside border. You have well-defined borders because you're limited by where the internet comes in or goes out. In the cloud, it can come from anywhere. Without properly defining your borders, you no longer have the luxury of inspecting one or two places as your border. Everywhere can be a border. So you have a number of compliance and administrative headaches if you don't properly say, these are my borders, and define them in your security design. Public cloud design and administrative knowledge, as each cloud provider has their own way of managing the cloud. Learning how to design and administer a cloud environment can be a steep learning curve. Some things in the cloud work completely different than in traditional networking. So asking your staff to learn public cloud can be like asking them to forget everything they know about networking and security and starting from scratch. Providers have their own terminology, their own interfaces, their own way of communicating for hosts. To add on to this layer, each provider is very different from the next. So some companies use multiple providers. The information learned from one provider often doesn't carry well to the next. So utilizing multiple providers means that multiple policies, multiple things have to be learned differently, adding further on to this learning pit. Lack of awareness about security in the cloud. Even among IT professionals, there is a lack of knowledge about the need of security in the cloud. Many still think that being in the cloud means it's secure, or only that security is required on the border. Public cloud security operates on a shared responsibility model, meaning the cloud providers are only responsible really for the physical hardware and their infrastructure. They're going to secure the physical server that your virtual machine sits on, but it's still your responsibility to protect the virtual machine itself from having its data accessed from the internet or from one of your other servers. Also, in IT professionals, knowing that the applications still need that same level of security as on-prem environments. A lot of this stems from when cloud was first introduced. It was mostly used for development and small testing environments off-prem. But the environments of today are much more sophisticated. They're connected directly back to your corporate data centers. They're touching your corporate data. They have to meet the same security standards as your physical on-prem security standards do. Your current security policies were probably created with physical servers or VMs in mind. They may not translate well to the public cloud environment, where many steps where things would be caught are not completed. Many changes might not be needed to the physical infrastructure. The policy may rely on changes that are never done because there are no equipment ordered. There are no changes to your physical firewalls on-prem. So your security policy may not have anything that applies to the public cloud environment. With all that in mind, let's take a look at what a development environment in the physical world might look like today. In this example, the company has a perimeter firewall, an internal firewall, and they've got a development sandbox sitting off the internal firewall. Anything in the development sandbox has to traverse the internal firewall. So shared services, going to the internet, all has to pass through this internal firewall. Nothing leaving the development sandbox can be accessed without involving the teams that manage the internal firewall and sometimes the team that manages the external firewall in a firewall change request. Because of this, developers are able to be given almost full autonomy in the development sandbox. They're completely isolated from the network. Now let's take a look at what this environment may look like in the cloud. In my example, I have assigned an engineer to create this in the cloud. I have no design, I have no policy for what my public cloud environment looks like. The engineer has simply read up on cloud and created the sandbox environment, trying to mimic what we have on-prem today. For my examples, I had to choose a cloud provider, as I said before, because cloud providers are very different and be very confusing if I jumped between them. So I'm using AWS as my cloud provider of choice. So you'll see VPC a lot. So 20-second crash course in AWS. VPC is virtual private cloud, and it's basically like a bucket to separate other networks or objects from other networks and objects. So with that out of the way, we can continue. So in this task, this is what the engineer came up with. The engineer was tasked to build my development sandbox in our AWS cloud. Since there was no pre-planned design, and he just went on AWS's, how do I do this? This is what he came up with. He created another account for development access. He created a VPC for the sandbox, and he created a VPC peering connection with the production account that was already in the AWS account. The engineer created accounts for all the current developers and made them administrators on the development account, since they have full autonomy in the current development sandbox. They were all assigned the administrator role in the account. For logs, the engineer configures CloudWatch, which is the AWS logging service, to flow into our SIEM. Connectivity-wise, this design will work. The developers are happy. They can develop. Everybody will be working. Everybody's happy. But from a security and compliance issue, there are a number of issues with this design. First, the developers are administrators, not of the servers themselves, but of the entire environment. So any developer has the power to remove any security controls I might add to the account, create accounts, delete accounts, open inbound connections from the internet, open outbound connections to the internet, add access, and many, many other things that you wouldn't want them doing. For access, they can add anything. Within the confines of the account, they have full control. There are no separations of duties. They have been given access far exceeding what they have in the physical environment today. And normally, because it's a development account, you might not mind if they have that, but because we've connected them to that production where there are production servers, that's a really big problem. User management's local. That engineer created a local account for all those engineers. So if an engineer leaves the company or comes on board to the company, someone has to manually go and add or delete them. There's no integration with our identity access management. So someone has to go and manually do that. And because the developers are admins, they can also go and add and remove and change people if they wanted to. They also have the ability to access from wherever they want. They can access from their home, the office, China, which also means that anybody with their credentials can access from any of those places and more. Both of the VPCs are internet edges, which in this small environment doesn't really matter, but as this environment grows, that's going to become a very large administrative issue. We haven't defined our network borders. We're going to have to control internet access from both access lists on both VPCs. As in administration, this is going to become a larger and larger headache. Same thing for VPC peering. For VPC peering, it's going to create access control lists that have to be controlled on both sides of the peering connection. Again, lots of manual access control lists that have to be managed. The level of logging is low. Just using the standard AWS logging doesn't meet most companies' compliance requirements. And we're just sending it to the SIM. So most places, troubleshooting-wise, that's not a lot of logs. So now that we've seen the security problems with this design, let's see what happens after a little growth. We had a few more projects. We've got no design. What happens after we get asked to add a few more things? This cloud is still relatively small for a cloud environment. It's hosting 2 internet-facing applications, a few different development environments, some data stores, and that primary subnet that we started with that has things like domain services and basic data that all the applications require. However, the effort to manage the security in this environment has grown exponentially. There are many more peering connections, each of which requires management of access control lists, and we've added 3 VPN tunnels back to the physical data center. Ongoing management of simple things such as access requests would be extremely time-consuming. This is before even taking into consideration things like IP schemes in each VPC, and if they were properly planned to not collide with each other or with our physical IP schemes that are back at our headquarters. With this example, you can see how quickly the administrative effort can go from being simple and manageable to spiraling out of control. Now that we've seen why a blueprint is needed, let's talk about how we go about building one. The security blueprint should be simple, repeatable, scalable, and adaptable. It is the foundation you will use to make all your design decisions in the cloud. Now, there are exceptions to every rule, and there will always be a time when a particular project won't work with your blueprint. Just like today, there are projects that don't fit within your physical security plans for your environment today. We all have that project that just doesn't meet what we allow in our environment, and we have to figure out how to make it work. Same is true, cloud doesn't make that easier. But you're the expert on your environment. You know how you do business. So that's why you keep that in mind when you're designing your blueprint. Everybody's blueprint is going to be different. If I could design a blueprint and hand each one of you, that would make me a very rich woman. Creating the blueprint may seem like a daunting task, but it can be a relatively simple process. After you've chosen your cloud provider, you break the security concerns up into large decision points and come to the best decision for your organization on each. These exercises can also provide information that should be added to your company's security policy to ensure it covers the cloud environment. I'm going to walk you through as I build a security blueprint for my fictional company's AWS environment. I'm going to use 5 categories, and for simplicity's sake, I'm not going to use any firewall clustering or load balancing. I'm also going to not include things that would normally be in my security decisions, such as IPS or web application firewalls, to keep this basic and within time. The very first decision an organization should be making is how you're going to manage identities. If we go back to the building of my AWS development environment, the engineer created accounts for all the developers in AWS and then emailed the users their passwords. This means the user's AWS authentication is not tied to any of the company's authentication methods. We already talked about how the users could log in from anywhere in the world. This solution carries a high amount of administrative cost and security concerns of people logging in with other people's credentials. So the first thing you have to decide what solution to use. That is all about what works best for you. You can integrate with the usual suspects: Active Directory, single sign-on, secure LDAP, etc. After you've chosen your identity provider, you need to decide if you're going to lock down access to your cloud to a set of source IPs. I would always recommend you set cloud management to only be accessible from the IPs at your physical locations. This is making changes to the fabric of your cloud. I would bet most of you have policies today that say making any changes to your switches, your routers, or your physical servers has to be done over VPN or from your physical offices. Making changes to your cloud environment should be no different. This is not the access that allows a developer to SSH into the server. That's still going to be controlled by firewall rules. You also have the option of requiring two-factor authentication. That decision relies solely on your company's compliance requirements and how sensitive you are to security. For my cloud, my decisions are going to be Active Directory and allow connections only from my corporate IPs. Your next category is going to be roles. It goes hand in hand with your identity access management. Roles are the rights that users are assigned in your cloud environment. In my cloud example, the developers were given the administrative role. In the public cloud, no one should be logging in with the administrative role on a day-to-day basis. The accounts that have the administrative role should be set aside and only used when major changes are being made to the cloud environment. The roles discussion in the cloud can seem overwhelming very quickly. There are a large amount of roles, actions that can be assigned. What you're looking for are the network-based, security-based, any action that could be used to create security or be used to bypass the security controls that you put in place. So the access that we're talking about in these discussions are changes to the fabric of your cloud. For the equivalent in your physical world, this is access to the actual equipment in the data center. So people that would be allowed to go with the data center and console into a device. Your decisions here won't affect the developer's ability to access their equipment, except for in the case of if you're using things like AWS's Lambda services to have a serverless infrastructure. Then your developers would need access directly into the management console. For our environment here, we're not going to use any of those services. But that is something to keep in mind. That's really the only time in your security blueprint that you're going to worry about what kind of roles the developers have. Otherwise, you're going to leave that to the development team. A large issue in the roles discussion from a security standpoint is who can purchase and what they can purchase. Now, some of you may be very confused as this is the cloud and you want people to be able to purchase things quickly, get servers up quickly, be very flexible and agile, as that's what cloud is all about. But with that speed and agility, there's a high cost. Let's look at a fictional developer using my sandbox, Bob. Bob is a fantastic developer, and we love him. And he got access to the development environment and got started right away. He got assigned high priority project A. And he's new to the environment, so he starts with 2 small servers. Then he also starts on project B. It needs a lot of processing power, so he grabs 1 large server for that project. Doing some work on project A, he realizes the small servers are undersized. So he creates a large and medium server to replace them. But he forgets to remove the small servers. He also begins work on another project, a side project that he has been meaning to work on for a while that improves functionality. Pet project 1. Now, he had to do a lot of work to move all that work from those small servers to those large servers in project A. He's very worried about getting burned again. So he's kind of done with the going with small servers. From now on, he's kind of always going to err on the side of larger is better. So project B now needs a second server, so he builds another large server, even though a medium one would have worked. Project A is now on hold indefinitely, but he doesn't tear down any of the servers. Project B is almost done, and he is assigned Project C. Starts with a medium and a large server. Now, it's obvious we love Bob for his developing skills and not his housekeeping skills. But with no need for approvals or anyone questioning why he was choosing the server size he was, he always erred on the side of larger, not wanting to go too small and having to move his content. He doesn't manage the cloud. He's not getting bills from the cloud provider. The cost of these servers that are just sitting out here is invisible to him. The cost of administrating this environment is invisible to him. So that was one developer over a small amount of time working on 3 company projects and 1 side project of his own. What does it look like with just a few more developers? Imagine the work involved in the administration of this environment. Are you sure all those servers meet your minimum security standards? Are they being patched? Are you tracking them in your inventory management system? Could you meet an audit on this environment today? Now, in my example, I used a development environment, but the same thing could happen in production. And when it comes audit time, you find a whole lot of servers that nobody knows who owns them, what they're for, or if you even need them anymore. This is what makes considering who can buy and how large they can buy such an important part of the rules discussion. Now, exactly how you go about implementing what you decide varies on what your tolerance is as an organization. There are many ways that you can go about limiting this depending on who you pick as your cloud provider and what your tolerance is. There are even software packages that you can purchase that will do this whole thing for you, from approvals to inventory tracking to management. For my AWS environment, I'm going to stick with very simple roles: network administration, security administration, compliance, and server engineering. In my fictional environment, we aren't using any AWS services, so developers don't need any access to my cloud console. For the next topic is traffic flow. This area in particular needs to be very flexible, as requirements will be different depending on the application that is being built. You'll want to work closely with networking to make decisions in this area. This is also the perfect time to devise the IP scheme for your cloud environment. Since this area needs to be agile, you want to focus on some basic questions. First, do you need to be able to connect to the cloud from the servers in your data center? If the answer is yes, you'll want to discuss the amount of data transferred and weigh the pros and cons of VPN versus direct connect versus going over the internet, and decide which is best for you now, which is best down the line, and how each of the designs may look so that you can build a foundation and build towards what will go in the future. Decide where your inbound and outbound internet boundaries are going to be in your public cloud. In the sandbox environment, most networks had been built with the capability of directly reaching the internet. You want to create a perimeter, just like you have in your physical environment today. For bandwidth availability or various other reasons, you might not be able to make it just as simple as 1 or 2 access points, but you can definitely still have a well-defined network perimeter. Lastly is how communication between hosts will be controlled. For this one, I'm going to go back to the main list and pick up our next topic, because while this is very much a traffic flow issue, the decisions about how you're going to address it has a lot to do with ease of administration. Because there are several possible ways the environment can be set up, and they will all work, but if you can't reasonably administer it going forward, those won't work for you. They're completely useless. The best tool in your arsenal on ease of use is use what works for you today. Most of the software vendors that you use in your environment today are available in the cloud. Your staff is currently trained on them. You currently have procedures for them. And other than the deployment, they usually work in the same ways. This reduces the learning curve in administration and often sometimes also reduces the cost. This also reduces how much you will be relying on the cloud's native security. This helps you in a number of different ways. Reduces your cloud learning curve, reduces the amount of policies and procedures that have to be built for the cloud, and it allows you to have your information be much more transportable. If you decide to go to a different cloud provider or a different security provider, it's much easier to transport rules from one security vendor to another than it is to try and figure out from multiple places of ACLs to another cloud or security vendor. It's always been my preference for the public cloud to deploy a virtual firewall for the public cloud. I'm keeping this vendor neutral, but if anybody wants to talk to me after about my preferred vendor, feel free to. If you create a very basic security policy in the cloud and deploy a virtual appliance in your cloud, being able to manage the policy there, it will look the same as your on-premise firewalls, and you'll also have a higher level of logging. Also on the traffic flow, this is a very large part where cloud providers differ. This is one of the largest places where cloud providers differ. So from going from one cloud to another, this is pretty much the place where one will be different from the other. So this is the largest learning curve for your staff. So communication between host, when taking both traffic flow and ease and administration into account, there is no one size fits all. And pretty much whatever your security policy is today, be that a 3-tiered approach or DMZ and then everything else, you're going to do in the cloud. And this discussion is going to be how you do that with your chosen cloud provider. For my AWS blueprint for the traffic flow and the ease of administration, I'm going to utilize VPCs to group my servers that don't require filtering in between them together. We saw how complicated managing the peering connections could become, so I'm going to utilize VPN connections to tunnel in between VPCs. Their VPNs are all going to be controlled by the security policy on virtual security appliances, including going back to my physical data center. And I'm going to have a central transit VPC for my internet connections and my VPNs. And I'm going to have an internet border for web inbound traffic and for anything going out for those VPNs. This brings us to the final section, which is logging requirements. And this one is very much a company by company basis because this is really tied to your compliance requirements and your troubleshooting requirements. Every organization is going to be different. If you're utilizing a virtual appliance, the way you intake logs might not change depending on which virtual appliance you use. If you're using the cloud providers, usually they don't meet standards, but if you have low compliance requirements and low troubleshooting requirements, it may meet your needs, or you may just need to upgrade what they have to the next level. It's all about taking what you need into account, looking at what's available, and making sure that you have it met. For our example here, I'm going to do that by having the CloudTrail service stream to CloudWatch and have CloudWatch stream to my SIEM. So now that I've completed my blueprint, let's take a look at that sandbox environment again. So this is the sandbox that we built. This is the blueprint that we just completed. Now let's look at what the sandbox looks like after I've applied my security blueprint. a lot better. We can see I've got my development sandbox VP'd into my transit VPC, where I've got my virtual security appliance that handles all my VPNs, so all my policy is on that appliance. I've got my production VPC, where it also has the VPN into my transit VPC, and I've got my internet gateway going out to the internet. So now we have our blueprint in place. We have no fear of growth or change. Let's grow and change. What does that environment look like after a few more projects? So we've added a link back to the physical data center. We've got inbound internet applications, and we've got further production applications. It's manageable, it's secure, and it all still fits within the blueprint. By making the time commitment to design the secure cloud blueprint at the beginning, you've ensured the large security issues are out of the way, and you are free to focus on the unique security risk of each new project. With the secure cloud blueprint, you are ready to secure the cloud at the speed your company is ready to use it. Thank you.